The 6 trigonometric functions. The 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. We're going to talk about the 6 of those in relation to the lovely angle and triangle you see at the right. Now, we can see here that we have a right triangle that exists in quadrant 1. And if we think about this, along the horizontal axis, we can see that x has a value of 4. And we can see that the y, or the vertical, has a value of 3. Now, if we're talking about, trig functions, we generally need all 3 sides of a right triangle. So at any point in time dealing with trig functions, if you know 2 of the 3 sides, we can then use the Pythagorean theorem in order to find the 3rd side. So here we could say 4 squared plus 3 squared equals c squared, or 16 plus 9 is c squared. And if c squared is 25, then c is 5. And we know it has to be positive because we are talking about distance, right? The length of a line, so it has to be positive here. So we call the hypotenuse r in our case for these examples, and r is always positive. That's just something to kind of keep in mind as you work through different things. So we're going to talk about the 6 trig functions in 2 different ways. So one way, the sine function, okay, and we're talking about the sine of theta, so we're looking at our central angle here. Sine is what we call the opposite over the hypotenuse. Well, the opposite side, you can see, is y, and the hypotenuse is r. So depending on the figure you have, if you just have a straight triangle, and you don't know y and r, you can use opposite over hypotenuse. If you do have particular values or, on a coordinate plane, you can use the y value over the r value because we know the r is the hypotenuse. For cosine, cosine is adjacent over the hypotenuse. So the side adjacent is the x, and the hypotenuse, again, is r. I guess we could also do these in numeric. So the sine would be 3 over 5, and the cosine would be 4 over 5. Sometimes numeric examples help as well. Then if we go to the tangent of an angle is the opposite side over the adjacent side. Well, the opposite side we know to be, again, y. The adjacent side is x. Numerically, that would be 3 over 4. Now, sometimes you will have radicals, and if there is a radical in the denominator, don't forget that we need to rationalize that because radicals in the denominator is not something we like to do with mathematics. All right, let's move on to the cosecant. Now, with cosecant, cosecant is simply the reciprocal of the sine function. So I like to say that the sine and the cosecant are, they're friends. So if we just flip it, that means the cosecant is the hypotenuse over the opposite, or r over y, or simply flip your sine. So the sine is 3/5, so that means the cosecant is 5/3. That works the same with the secant. So secant is the reciprocal of the cosine, which would make it the hypotenuse over the adjacent, or r over x, or we simply flip the numerical value. So if I'm asked for the cosecant or the secant or even the cotangent, sometimes I'll find the sine and the cosine first and then just flip my answer because it makes it just a little bit easier. So for the cotangent, we know that that's 1 over the tangent. So that's the adjacent over the opposite, or x over y. Again, just flip it. So these 3 are simply the reciprocal of their partner function.